Hello, and welcome to today's web seminar, Application Testing Challenges, Theories, Tools, and Technology, featuring Reg Struck, Product Manager at Polarian, and Jim Trenadu, Sales Manager at Ranorex. I'm your host and moderator, Josiah Renaudin. Thank you for joining us today. Before I hand it off to the speakers, let me explain the controls on this console. If you experience any technical issues, please send a note through the question field located beneath the panels, and we'll be on hand to help as quickly as possible. Our responses can be read in the QA panel to the left of the slides. This is also the same way to submit questions. We welcome all comments and inquiries during today's event, so feel free to ask as many as you'd like, and we'll answer as many as possible during the QA session after the presentation. This event contains polling questions, which can be answered within the slide view. To optimize your bandwidth for the best viewing experience possible, please close any unnecessary applications that may be running in the background. At the bottom of your console is a widget toolbar. These widgets open panels. The console opens with three on your screen: the speaker, QA, and the slide panels. All of these panels can be moved around and resized to your liking. If you accidentally close one, click the respective widget to reopen the panel in its original place. Hover your cursor over these icons to reveal labels identifying each widget. Through these icons, you can download the speaker's slides and share the event with friends and colleagues. You can also find additional documents, data sheets, a case study, and links to additional videos in the Handouts folder. This event is being recorded and will be made available for on-demand viewing. Once the recording is ready, you'll receive an email with instructions on how to access the presentation and slides on demand. With that said, I'd like to introduce and pass the controls to our first speaker, Reg.
Thank you, Josiah. Thank you, SQE, and welcome everyone who's attending today's 1-hour webinar. Just first, before we start, I just want to mention that both Jim and I are actually newbies to using InXpose, so bear with us if there are some small technical glitches, but I hope there won't be any today. So what we're going to cover today, actually probably should tell you first a little bit about my background. Primarily in today, my expertise, or domain expertise, is in software testing and the integration of various software technologies to software testing and ALM. But I have over 20 years plus experience as well. And Jim is also responsible for QA, actually the roadmap on Ranorex, which he'll talk a little bit about. And then he has, obviously, 16 plus years of experience in software quality and testing as well. So briefly, I'll talk about the agenda. We'll talk about the evolution of testing, theories of testing, tools and technology that are associated with testing, a couple of case studies that are pretty interesting, and how we implemented some of the testing that we'll talk about today. And then we'll follow that up with question and answers, hopefully for 10-15 minutes of Q&A. A little bit of housekeeping. Probably a good idea to talk about who we are. So Polarian was founded actually in 2004. We had a disruptive vision. One of the primary reasons for that is because we're a 100%, or at the time, we were a 100% browser-based ALM solution. We're actually web agnostic. We don't care what browser you use, and it's ISP-based, so you can either host your own or have it host through Amazon services. A few other things about it. Full traceability, I'll talk a little bit about that in our ALM session, real-time collaboration, and a very intuitive user interface. Is that we've actually been around for 10 years now, 10 plus years, and we've actually 49% growth since, well, in 2013, but year over year we've had phenomenal growth. And recently announced, we're proud to announce that we've had an investment infusion of $10 million from Siemens. I'll talk a little bit more about our ALM solution, but in essence, we actually are a software manufacturer of ALM, requires management, and obviously software testing. So what we talk about today, and Jim as well, is that we eat and breathe with some of the theories and methodologies and challenges that we'll discuss today. Global presence. We're all over the world. strong ecosystem that is fostered by a very large reseller partners channel, as you can see worldwide, and then cemented by our technology partners. So a key area of our products, and one of the insights that I'll have for today, is our technology partners with various integrations into our testing tools. And of course, we've got lots of customers worldwide. Now, let's get to the good part. Okay, so talk about the evolution. Now, believe it or not, when I was doing my research, surprising enough, software development and testing has actually been around since 1820s. And that is when humans actually started to create machines that could do computational exercises and had to be tested, which was pretty much a revelation for me. So in today's presentation, what I'm going to do, I'm not going to start obviously in 1820s, but I'm going to actually highlight some of the watershed moments that have had a significant impact on software testing. And I'll start with, well, everybody probably knows this one, but it's the waterfall software development, and that was circa 1970. And really what it was is, if you're not familiar with it, it's a linear phased approach. And really what we do is it's a gate, I'd like to call it from my experience. And it came from manufacturing construction industries, interesting enough. Strict waterfall approach is actually discouraged by many critics because of its inflexibility. And pure waterfall model really has been a source of criticism over years. And it's probably hence why some of these other, I'd say more new improved methodologies have come around in the last 3 or 4 decades. Testing does not occur until near the end of the waterfall release. So if you look at this particular graphic, it's actually verification, validation, which is just before maintenance and release of product. Each phase is independent of each other, and each phase has to be completed before you move on to the next. So you can see there's a lot of challenges for testing. Primarily, I would say, is time constraints for fixing your defects and properly testing the software to your user needs and requirements. Then, another watershed moment, I would say, is the V model, which is another common known methodology. And that was circa 1986. If you look at this graph, you see hence the V. Really what the V model is, it's very engineering focused. Introduced in 1986, like I mentioned, it became an extension of the waterfall methodology. And what that really did is each phase now had processes that performed sequentially. You'll know as more commonly known as verification and validation. And really what that means is ensure that the correct product is being built per your requirements and your actual user needs. As you'll notice on the right-hand side, testing has been introduced at each phase of the process. So for example, we do analysis and then acceptance testing, preliminary design, system testing. So a real revolutionary in the sense of having testing in each corresponding phase of development. Also to note, in 1986, which I found interesting, is that SQE was founded. And maybe some of our colleagues here from SQE might not even know that. It was founded, which was, as you all know, was instrumental in promoting testing as a distinct discipline. And here we are today. So a nice little tidbit to digest. Next, in these processes became what I would call formalization of test cases, which was around roughly, and this is debatable, but around 1987 is when we started actually formalizing structure around test cases. And really, if you look look at this particular, this is actually the workflow in Polarian. So we have the test case, and then creating the process of a test specification document, and then the framework for executing those tests, and then obviously the results. So that was actually in 1987. And then another one that I find very important is exploratory testing, which was around 1988. Hard to believe that it's been over 2.5 decades that exploratory testing actually came into existence. And really what that is that does it do what it's supposed to do? And what else does it do? And we'll talk a little bit more about in theory about exploratory testing. But the concept was introduced by a fellow by the name of Sem Kainer in his book called Testing Computer Software. And he extended an introductory chapter on exploratory testing, which really started the thought process in exploratory testing. Jim, I'll hand it over to you for automated testing.
Okay, thanks, Reg. So one of the things I want to talk a little bit about is automated testing and kind of where that came about as well. So for some people that remember some of the medium-sized companies that have now been purchased by very large computer enterprises, some of the first record and playback tools appeared about 20, 25 years ago. So there are a handful of tools out there that you see. Their objective, I mean, back then, the only objective was to test desktop applications, right? So that just your legacy, whether it's Dell 5 VB, C++, anything you have. There were some initial functionalities that to say if there was a website, you could test broken URL links, but not really dig into the object verification or recognition like they did for desktop. The tester was required to have scripting or programming knowledge to make the test run effectively. So these were tools that said they were record and playback, but we found a lot of problems because we found that the testers really had to have an in-depth knowledge of how to write code, basically whether it's in C++ or VB, anything like that. You've had to have that kind of background to really make your tests run. Some of the evolution of the test automation frameworks throughout time is initially there was a record and playback, followed by some structure testing, invoking a little bit more condition-based test into your recorded scripts. Then came the whole process of data-driven testing. How do I take data permutations and run those through, loop those through my test, just a series of data? How do I take that and progress that even further to make it a keyword-driven approach? So every time the mouse clicks here, every time the keyword of an input field, something to drive to say this is what I want to test, and here's the values that correlate with that. Now to a model or object-based. So we have a given model or given object that we want to test, and how do we structure our sequence of tests around that? More evolved is an actions-based test. So every action this is where we're starting to, you can see this starting to come full circle, because an action-based test really is trying to tie into that manual test, as Reg alluded to as well, to get that manual framework and make that appear very transparent to your manual tester who's trying to do automation. So this evolution is really trying to make the manual tester more involved in automated testing. So then finally, a hybrid may take two or more of the previous frameworks and just combine that in together. So Reg, I'll turn that back over to you.
Thanks, Jim. All right, so from automated testing, we go on to one of the most recognizable and probably most debatable methodologies that are available, and that is Agile, which was circa 2001. This was really when they published the Agile, the famous or infamous, depending on who you speak to, manifesto. And what this really did is really put a lot of interesting concepts into the software development process. Obviously, the key one is creating development in iterations of anything from a couple of days to a range of 2 weeks, where development is boxed into small iterations, and the entire process is rapidly done through those iterations. So it's what it is time-box development. It's very leap forward in software development, but it does have some very unique testing challenges, as well as most of the people that they're in testing on this particular presentation will be able to confer with that. Another one that's fairly recent, although it did actually appear in 2008, which was something that I was kind of surprised about. I had not heard about crowdsourced testing, at least. Crowdsourcing certainly in the last decade, but crowdsourced testing I had heard quite a bit. And that actually came around in 2008. Really what it is, it's the offering of software to large and diverse software testing communities outside of your internal corporation. All right, so we've got a nice little poll here. And if you could click on one of these, so I just want to see what percentage of people use the most common software development methodologies in their corporations. I'll give you about a minute. And about 10 more seconds. Great. Yeah, let's review the results. And I apologize if you were not able to actually engage in this little poll. Interesting. So, which is very much what we had thought, or you could predict, is that Agile is actually the overwhelming methodology used in today's software development environment. I'd probably lump in that is the fact that Agile, I would say, is a catch-all for all, and this is just in this particular context, but a catch-all for all the hybrids that, or deviants of Agile, so Scrum, etc. Because I haven't found, at least in my experience, maybe Jim found differently, but in my experience, I haven't found a true Agile company that uses a true Agile based manifesto. So there are certainly deviants. What's still interesting, though, and predictable as well, is that waterfall is very much still in use throughout the world. So that's quite interesting. All right, so we're going to move on to theory. And so we spoke about the evolution of software testing, but in this section, what I want to talk about is the various theories, or Jim and I will talk about the various theories of testing for software development based on those watershed events that we discussed. So Jim, first off, test automation.
So, all right, thanks, Reg. Some of the questions to ask when we're in theory of either enhancing your test automation effort or implementing it from the start is these are some good questions to ask yourself and organization to kind of be prepared for how you're going to be rolling this out. So when I start with the who are the right people to create and maintain the test cases, object repository information? So a lot of the test automation relies on object recognition, but there's still, you're building your test cases in that same vein. How do you structure your tests, and who are the right people to be creating this? Who may execute automated tests instead of creating? So you may have a test automation team that builds some of the tests, and then you have some users that just can go into an application and just pick the test to run to save time on regression. Who will be the dedicated go-to persons for the tool? So basically your champion. You know, who's going to be the person that's going to look for updates, be that SME for it? What is our organizational's definition of automated testing? What it is and what it's not. So is it going to be everything that's going to be that silver bullet? Or do we say we want to automate this much regression and this much new features, really more metric-based? What are the test automation objectives? So we want to automate this much by the end of the year. We want to continue growth in automation by 20% over the next 6 months. What are our objectives for that? And again, it's not to automate an entire application, just to be broad stroke like that. What is the expected testing coverage sought after with test automation? So this really is looking at your application, looking at your organization, and really determining what are the test cases or the test areas that are better served to be automated as opposed to some manual intervention. When are the testing resources available for this initiative? So is this something that we need to make sure that you are doing automation as a separate initiative? You're not trying to just squeeze it in. You have a project release cycle that's a 4-month cycle, and now you're going to try to fit in automation, replacing a manual sprint or a manual test cycle with automation just kind of in between. When can happen training in relation to the procurement? I say this because a lot of organizations now seem to be going with a just-in-time training. So not to train on an application or any new tool that you have 6 months prior to you using it, and then forgetting about what you need to do. So how can we schedule that training right in time for when we're going to procure it? When are there project deadlines that compete against test automation? So if we know we have a big end of Q3 release that's going on sometime at the end of September, maybe test automation is a 4th quarter initiative. If we know we're not going to be doing that, we line up our procurement or training something around those times. Where will the test automation take place? Is there a dedicated test environment? So we want to have some reliability with what we're expecting. We can do data-driven testing and keyword testing, but we want to make sure that it's at least a stable environment that we're working in, at least to gather a good baseline to start. Where are the associates located? This is going to decide whether a training should be remote, on-site, online, anything like that, that it has to be a hybrid. If you're co-located with your testers, again, that might be something that either bring them together or do something remote. Where will a central repository reside? So you don't want same versions. Again, this just goes back to some standard version control. You don't want to have floating different versions of a test case or some kind of recording that you have that's floating around in 3 or 4 different locations that's essentially the same one. You want to try to make that in your repository as much as possible. Why start a test automation initiative? What are the specific issues? So everything's got to be a catalyst for something. So to say, if we want to start something, a test automation effort, it's because we want to try to improve our time to market. We want to try to improve our testing productivity. We want to try to free up some of the testers' time to do this. Something is driving why we want to do test automation. Why run a vendor POC program? What do we want from this assessment? So there's a lot of vendors out there now, at least probably a good 20, 25 that say that they can automate and hit all of the areas, as far as what we want from a mobile or web desktop applications. But why don't they prove it? Go out there and just say, vendors, show me that your software can work and it's going to be simple enough for my manual testers to use. Why start with a top-down management approach? So why get management buy-in? All right, why not just start with a tester and say, hey, this is a pretty cool tool. Let's just try this out. We really want to get the management's approval because it's going to affect much more than just the testing team. There may be some development resources. There may be some infrastructure, network, DBA resources that are required for at least contributing to the initial success of this effort. How about how? How do our test automation objectives differ from our overall testing objectives? So in our overall strategy document, we want to make sure that we outline what our automation objectives are for a particular release or for an application that differ from our overall testing, because we know that there's going to be some portions of manual testing that are absolutely going to be required. What's that percentage? Is it 50%? Is it 30% automation? Is it 70% automation? But tie that into your overall testing objectives. How does manual testing fit into a test automation framework? So we want to make sure anything we go with, if we're going to transition manual testers into a test automation role, we want to make sure that they can easily port their SME knowledge of the application and not be so much overhead that they have to learn how to program, learn how to code. That's just not prudent, and it's not something that a typical manual tester wants to do. how do existing tools such as continuous integration, configuration management, test management solutions, again, a lot what Polarion offers, work with the automated solution like Ranorex? So how does that tie in to say that, how does that Ranorex integration with Polarion look? And how can I work with both solutions? So this is something to keep in mind as well. So Ranorex, Polarion, we do have a great integration, but that's something to constantly keep in mind that if I have one tool, do I have to now go replace it because I have another tool already that I'm using? So that's not something that we certainly want to go down that route. So one more slide here. Here's some theories, though, to disprove as well, or some misnomers, I should say. Test automation automates manual test cases. Well, to a degree, but maybe not. With automation, you may find that you automate different areas. So something may be better served to do an automated test versus something may be better served to do a manual test. So automated test cases, they're separate from manual test cases with entry points, data, criteria. When you're thinking of creating your manual test case, you're not thinking I'm going to create one step or one test case maybe specifically for logging into an application. And that may be the only step in the test case. That's probably not going to happen in a manual world, but in an automated world, that could be very modular and very easy for other people to use. Error handling is an essential part of automated test cases, separate from defect detection. So we want to make sure not only that the script itself has ways to get out. So if it comes across an unexpected active window, what happens? Manual world, you just click it and move on. If something, you get a network message that your antivirus is running, you just click it and move on. For automated testing, you have to tune it and tell it what to do. Modularity is the approach on how automated test cases are developed to ensure reusability for each automated test step. So from a manual test case perspective, you're writing the steps that you want to do to execute that. Not necessarily thinking, I need to retype that step, log into this, or reuse that. If it's repeated, if a step or two is repeated within a manual test case or two, probably not a big deal. For automation, you really want to try to streamline that so when you do get errors, you can pinpoint exactly where that is and you don't have such bulky steps along the way. So to answer that, test automation automates manual test cases. Actually, test automation objectives aim for the highest ROI, whether that's automating manual test cases or blazing in a new area. Test automation must cover 100% of the application. So testers start automation with a regression library, but focus on tests that are time-consuming and have an high ROI. Typically, people say, I want to get automation, so I have 500, 1,000, 2,000 regression test cases I want to have automated. Application changes need to be planned for in a master test plan and automated during a maintenance window. So again, that whole master test plan test strategy document, consider your automation of what needs to change as part of it, because that should be allocated as part of your testing time for your associates to make sure they make the tweaks to those test cases. Any automation failure needs to be analyzed, whether that defect is in the automated test case or system under test. So this is something that doesn't typically happen. You're not necessarily going to open up a defect on a problem that you had with your manual test case. There could be a defect in the requirements, defect in design, defect in code, but us as testers, we're typically just going to edit the manual test case. If we get problems with our automated case and it's either working with bad data or the fields are off, we could be reporting application errors that aren't as such. It's just some of the automation scripting or automation test cases that kind of went awry a little bit. So should test automation cover 100% of the application? No. You know what? Look at the test plan. And audit that includes both automated and manual test cases to form that 100% coverage. Again, not just from test automation perspective. Testers can automate their tests during a release. The initial cycle of creating and executing an automated test, it's definitely going to be longer than manual tests, right? Because you're going through your recording, you're tweaking, you're tuning, and once you have that as robust as possible, those run times should be reduced. Manual testers are going to require training on the automation tool. It is a new tool, a new application, so how do we schedule that in outside of any kind of critical release timing. And finally, test automation should be a separate initiative, defined with its own goals and objectives. So you want to make sure, not just within a given release, if you're going to buy a tool, you want to make sure, does it work? I have web applications. I got to support IE, Chrome, Firefox, Safari. Does it support all those? Does it support my legacy desktop applications? We are going to be going mobile shortly, either mobile website rendering or mobile applications. Can I work with a tool that has all three? That's what we really want to drive to, not just looking at automating my tests during a given release for my web application. Let's look across the entire enterprise. So testers can automate their tests during a release. Separate goals and timelines for test automation should be there. We need to have that to make sure that we have the best tool and adoption across the enterprise, which is going to be much more welcomed in the organization. So, Reg, I'll turn that back over to you now.
Thanks, Jim. Well, exploratory testing, we mentioned it as a significant event in the evolution of testing. It's really coming to its own now. Since Cambridge formally introduced it in '88, the concept has readily evolved and is quite readily actually accepted as a viable testing resource and even a domain of expertise. Most of you have probably read or even experienced workshops from the James Box of the world and so on and so forth. Just to step back a bit, what is it? Well, it's exploring how the software actually works and behaves in the real world. What does that really mean? It means testing of software without any specific formalized test plans and schedules. So a really good example would be GUI interface testing. So just exploring a GUI haphazardly through user experience and documenting the activities and the experience. What's really key, though, is testers really have to understand the application first, by exploring the application and really getting a good understanding of what those test scenarios are. Some key advantages as well. Accelerates ideas for authoring test cases. So if you get to be intuitive about your product, then you're going to get better ideas, generate more in-depth ideas for authoring test cases. So good that way. Other advantages, well, it doesn't require any prep time or documentation. If anybody that's experienced exploratory testing, which I have, which is kind of cool, is that it's just time sessions and go and basically do, there's a loose script of what you have to do and just go and do the user experience. And can save time in certain instances. And then also you can generate lots of different issues. And I think this was a good quote I found in doing my research. So the essence of exploratory testing is that you learn while you test and you design your test based on what you are learning. Good way to sum up exploratory testing. I wanted to include this because there are tools that are actually starting to come to the forefront for exploratory testing. Some good, some not so good. I'd say that it's still somewhat in its infancy. But there is a good tool for actually mapping out your exploratory testing activities. And in this example, it's MindMap, and actually you can get it for free. I'm sure most of you are familiar with it, so it's obviously chart-based. But a really good tool. I just wanted to use this as an example. And certainly, if you have not used MindMap, feel free to Google it. I think you'll like using it, especially with if you're doing any kind of exploratory testing. All right, so back to agile testing. So we talked about it as a major event in software development and testing. But let's go a little bit more in detail about some of the theory. Well, this isn't theory, but this is, and the polls certainly substantiated this, is it's here to stay. No doubt about it. It's gone mainstream. And with that, though, is we face some significant testing challenges. Not all bad, not all good, but certainly we face some. So first, and in no shape or form are these all the most comprehensive list of challenges with testing with an agile methodology. What I've tried to, or attempted to do here is best on user experience and talking to colleagues and researchers, I call it maybe the top 4, at least from my humble opinion, of the challenges with testing in an agile world. So number 1, test coverage. So what do I mean by that? Well, with it's basically, you're looking at now, the other thing that comes into agile testing is continuous integration. But really what's happening is you're rapidly changing your development environment, and then your requirements are always shifting. So one of the things is that you can obviously miss critical tests for covering your requirements, which obviously could be a bad thing. The way to get around this, from my experience, is mitigate this by using some kind of linking system between your requirements. Hopefully you have user stories in your test cases, and ultimately defects that circle back from that, and source control as well. So definitely some kind of linking system. Commonly you'll find that in software, and we'll talk about that in the software section as well. Second, frequent builds. Again, coming back to the continuous integration. Well, the reality is that in any kind of flavor of Agile, you're going to have your code is changing, probably being compiled daily, and the likelihood of your code breaking some of your features when you do a build is very high. I'm sure we've all experienced this. One of the solutions for this is to run your test over and over on each build, not necessarily all your tests. And would have been a good segue for Jim in his past 2 slides, but really what we're talking about is test automation. So some kind of, when you're doing a build, some kind of test automation to cover at least the basics. Oh, so there's my glitch. User error, told you. All right. Number 3, defect detection. So what I mean by this is basically getting to defects early. So we've all heard of test early, test often. Really, what it comes down to is that we all know, and we've seen lots of research on it, is that the further down the software development process that you find your defects, the more expensive it is to actually fix them. So obviously, the test often and test frequently and test early is really the way that I would say to mitigate this. Using things like frequent code reviews, but also implementing tools. So static code analysis tools is a good example of that. But there's various methods, various ways. The last in this, I'd say that on the top 4 at least, is performance bottlenecks. So this really comes down to maturity model. As products become more complex, so as they mature, really is what it comes down to. Doesn't matter how easy it is to use a product. As a product gets more and more code involved into it, then there's obviously going to be some new issues. And one of those is with that complexity, with the additional lines of code, is you're probably going to start introducing at some point a threshold of performance issues. So certainly that is, especially with you're doing more iterations, you're building more code, chances are you get to that threshold quicker than you did in the past years with other methodologies. Mitigate this, the biggest is obviously tools. So I would highly recommend, and this is not an endorsement, but load testing tools. Examples, LoadRunner, Loadster, there's a whole bevy of those out in the marketplace, but certainly that's what I would be looking at. Crowdsourcing. So I don't know why this is one of my favorites, and maybe it's because some of the case studies that I've looked at, and one of those ones, actually both I'm going to present today, have some kind of flavor of crowdsourced testing in it. First, it is definitely growing in popularity. As I mentioned, it was around, 2000 and something that it was introduced, but it's really in the last couple of years that it's really, really growing in popularity. So what really is it? Well, in a nutshell, it's basically obtaining needed services, your testing services, from a large community outside of your organization. So it can be a group of people, it can be a group of organizations, it could be a club even. So, but really it's an online community that hopefully has some kind of domain expertise or a series of domain expertise of what you want tested. So rather than using your traditional employees or suppliers. And we would commonly know this, or it's been commonly known, at least in the last little while, as testing in the wild. So testing services for large and specialized groups. Key to this, I'd say, is there are some very focused areas that you can quickly look at. GUI testing, beta testing, localization. So things that you could certainly, are very popular with crowdsourced testing. And I'll give examples of that as we move forward. But why do we do it? Ultimately, it's going to save you, or it can, or it should, save you time. So in this type of testing, you should save time because there's multiple tasks that you are actually sourcing out to external resources, and you're sourcing it to a large user community. The last part of this is, and I found this quote recently, and it's from Jeff Howe, from he's an editor of Wired magazine. It's not outsourcing, it's crowdsourcing. So I thought that was quite, I guess, interesting. Security testing. There in the past, and I'm not sure exactly why there hasn't been as much in the last few years, but certainly security testing, and I think it'll become more at the forefront again, certainly from the website, and now that we're all going to mobile devices. But really what we're coming down to is it's detecting vulnerabilities, okay? But make sure that everybody's aware. So even if we bolt down the hatches and we're looking at intrusions and all those kind of things, is that even if you put a framework in place, it's not all secure. So you can, best intentions intending to reveal the flaws in the security mechanisms of your system, but there are logical limits in when you're dealing with security testing. So passing security testing is not, by all means, an indication that there isn't any flaws in your system. What you are doing is you're adequately satisfying the security requirements of your product, or even more stringent might be regulatory as well. As I mentioned, web-based is certainly where the biggest source of data breaches are. In fact, it's in a recent survey, almost all organizations, that was the biggest source, was web-based and mobile applications, which ultimately is web-based as well. So that can create great opportunities for hackers, but then as well as that, it creates new roles for testers. So what do we do? Well, you want to test, for example, all the roles and rights you could actually think of for permissions on your device to access your software, including the administration, webmaster, etc. So there are countless new opportunities if you look at it that way as well. And I'd say that you'd want to have a combination of a security testing framework, which includes processes, a plan, and then the appropriate tools to execute that plan. So probably a combination of test automation, code analysis, and then some actual, even exploratory, for example, for trying to get into, for example, malicious access to your product as well. Example of companies that cover a lot of this, Veracode is a really good example of that as well. All right, so we talked about the history, we talked about the theory, now we're going to talk about some of the tools. Now there are several dozen categories of tools in testing, as everybody can appreciate. But what we're going to do today is we're going to focus on a couple for sake of time and importance and relevance to this presentation. And I'll pass over to Jim for test automation.
Okay, thanks, Reg. So in the space of test automation, there's a number of tools that have increased. Again, we were talking, think of back from the evolution slide I was referring to, a handful, maybe 4 or 5 tools 20, 25 years ago. Now there's probably about 25, 30. And they're largely, when we talked about that skill set required to have a programming background, largely in part now, these tools are trying to take away the scripting and programming. But just be careful on that, because some, as much as some is advertised, run that POC to see how much scripting is required. Make sure, again, the technical complexities, these tools now, they really should cover a variety of the desktop, web, and mobile, because it's going to cover everything, right? You need to make sure that all your web browsers that you have are covered, all the mobile platforms are covered. In addition to the operating systems and everything like that, the permutations of testing now could be increased tenfold. License models, now, back in the evolution, there was just the concept of having the licensed software. But there's now license models to have a test execution only component. So the concept that I'm a test automation person and I can make sure I automate all my tests for the testers, and all they have to do is go into the tool, pick the test cases they want to run, and just run them. It's already given for them. If they have any problems, they bring it back to me. So it's a little bit more flexible to work with the manual testers as well. The tools should have the capability, because now there's other tools that, as Reg was talking about, that support the entire life cycle. Continuous integration, test management, config management. So any tool should be able to intermix with any of the tools that you have out there. So whether any of the test management solutions you may have, any of the continuous integration, it should be able to tie in seamlessly to all those to make sure it's one continuous flow. Reg, back to you.
Thank you, Jim. All right, so I'm obviously, no surprise here, going to talk about ALM, so Application Lifecycle Management. It always amazes me. Gartner estimates that the ALM market currently is about $1.5 billion and growing, so a very large marketplace for ALM. A lot of that, quite frankly, in the last while is fueled by Agile and Cloud, and there's various reasons for that. A lot of to do with managing so many different activities, also having external resources that are infused into this. So there's a lot of things that really what I would call busy that we're getting into, and market pressures that we have to deliver faster and better. A bit about ALM is the emphasis is really on planning and managing and executing software projects. So it's not the focus on the tools themselves, or it shouldn't be the focus on the tools themselves, but it's on the overall project itself and basically being able to improve those efficiencies. Good news is ALM has really evolved and expanded for the user's needs in the last few years. It provides structure to manage all those processes, and it delivers specifically the results. So that's where your ALM should shine. If it's not providing you that project structure and you're not getting results, then I'd say that you probably want to look at what's broken in that particular process. As I mentioned, it's a project-focused philosophy. So what we want to do is ALM in theory should be able to improve your efficiencies. Because nowadays we're a globally distributed environment. Chances are your teams are all over the place. They're dispersed all over the world. They're probably working with more than one methodology, and they certainly are working with more than one tool. So how do you manage all that? Well, that's where ALM comes into the forefront. Is really what you're looking at is that you're controlling all of your processes and tools under one system. I mentioned an example about linking for Agile. That is one of the areas you can link all your requirements to your testing framework all the way to your source control. Manage your processes, whether it's Waterfall, V-Model, Scrum, or whatever one you're using. And I just wanted to highlight, now this is, I showed this at the beginning on our product focus, but really what it is it shows you all the various tools that you would use, and the central is the LM, so that's managing all those. So really what it is that, for example, even Ranorex, all the tools that you would use would actually, all the results would be managed through the ALM process. All right, so very quick, we're getting close to time here, but very, very, very quickly. Another one. So what tools, theories do you use in your organization? And I'll give, say, 30 seconds to complete this particular survey. Once we get to about 75%, which we're going to get there very quickly, then we'll move forward. And we're over 70 already. Great. Awesome. All right. Okay, some interesting results. Test automation, which I'm really happy to see, and I'm sure Jim is ecstatic to see, is at the top of what kind of tools and theories are actually implemented in your organization. As expected, so 21% ALM, and why Gartner says, and many others, the growth that's there. What's really interesting is the exploratory and crowdsourcing. So actually it's gaining in 6%. Exploratory is all the way up to 28%, so it really lends credence to the fact that it is now a domain. Awesome. All right. This is two case studies I want to talk about. So, but really what they are is examples. So I wanted to provide real-world examples of companies that have had some challenges in testing, and that have evolved their testing in the context of some of the concepts that we talked about today. First and foremost, everybody's familiar with this, Mozilla Firefox. So the first of Firefox's web browsers was actually released in 2004, and not surprising, there wasn't any test automation actually at that time. It was 100% manual testing. What was interesting is it was some real issues in the sense of resources. It was very resource intensive to test it. Had multiple issues. If you remember, I'm old enough to remember back when it first came out, there were multiple issues. Performance was definitely a big one, but it always, there was lots of crashing, I remember. And then the other one was add-ons. So although it was limited in the number of add-ons it had back then, there was definitely some issues with having them work and then also crashing your system. What's interesting too is that I came across a survey that Mozilla Firefox, actually web browser, even today, well, by today, is actually the most preferred browser by both developers and testers. So I can tell you from the next slide, it's come a long ways. So what did they do to actually fix that? Well, the first thing they did is in 2011, they decided to release every 6 weeks on Tuesday of every 6 weeks, which actually what it ended up doing is it created even more issues. What happened is that add-on compatibility, so the various vendors, in fact, I'll do a plug-in here for Jim. Ranorex actually has an add-on for Mozilla Firefox browser, but it created some real issues with every time that there was a release, the poor vendors could not keep up with the current iterations, and it just made a mess of being able to work cleanly with these particular add-ons. And performance took a hit. So slowly what ended up happening is they started to bring in test automation. There we go. How did they do this? Well, they actually, believe it or not, introduced crowdsourced testing. Yeah, believe it or not. Firefox actually created what was called the MozMil, okay, extension. And what it is a test tool. You can go Google it, and a framework for actually writing automated tests. It's really for basically not just the user community at large, but obviously the companies that create add-ons for actual Firefox. And the result is that they actually have increased their testing automation, obviously more than 30%. But more importantly, actually what's happened is that now they only require one single resource internally for 192 different updates and 5 different platforms. So it's greatly enhanced, and if anybody that uses Firefox can happily say that it's actually a fairly good browser to be using at this point. All right, so second one, Xbox. So I'm sure not everybody here is a gamer, but they obviously know Microsoft Xbox. And Xbox, well, when it was first introduced, and I know because I have a teenage son, it had a ridiculous failure rate in the industry compared to other companies and competitors, in fact. So, in fact, it would crash so often that they had to extend, Microsoft had to extend the warranty to 3 years because of market pressures. And then the competitors were very, very quickly catching up. So multiple crashes in the first 5 years, and a PC Magazine actually did a survey and of the top 3 vendors in the gaming consoles, and Microsoft actually had a 54% failure rate. So it was a real hit for Microsoft and any of the companies that actually produce games for them. So what did they do? Well, they created a couple of things. So the first is they created the Xbox AXTP, okay, which is actually their test program that is authorized to their to third parties. In essence, what they did is it's crowdsourcing, but it's a controlled crowdsourcing, far more controlled than what's been done with Firefox. And they've allowed it so every year you're allowed to apply to become a member of the Xbox AXTP testing framework. Then they launched this year the One beta program. And what this is that you can, any individual can actually sign up now to test the any iteration of Xbox before it rolls out to the masses on a regular basis. And what's ended up happening is that, and that's certainly, so test more frequently into a wider audience. The net result on that is they've got definitely better performance, almost unheard of system failures, and their market share has increased. For those of you that would know Halo, increased exponentially in the last few years. So both case studies, which were very interesting, is that they've both had some major issues, both introduced some form of crowdsourcing, and certainly opened up testing to outside resources. So I was quite amazed by those two in reference to that. And of course, Firefox, a lot of it went to test automation as well. So great. Now we're almost at the hour, but we can do some Q&A.
All right, thank you very much. Like you said, we're running a bit short on time. We'll be able to do about 2 questions before the end. Before we start QA, remember you can ask Reg and Jim questions by typing it in the field beneath the panels and then click the Submit button. We'll try to get through as many questions as possible. For those questions we're unable to answer during QA, some will be answered offline. The first question is, what is variant management?
All right, Jim, did you want to answer that?
No, I'm sorry. That's Reg, I believe that's for you for variant management.
Oh, okay. All right. So talking about variant management. So really what it is it's the variance and the differences, degrees of configurations that you can have in your software development process. So there's actually an entire hierarchy of that from a variant management point of view. You can have things like the data, so configuration of your data, also various variables that you'd put into that. It's used very heavily in basically products like Simulink, so model-based components. So really what it comes down to is the various degrees we actually integrate with Simulink from MathWorks, and we actually can take the both the what they call the diagrams and that and the requirements, manage it through our requirements, and then ultimately, if you have tests with that, link it to those tests, the requirements with the variants, and test that, and obviously manage those results.
All right, thank you very much. And this will be our last question. How popular is crowdsourced testing, and how does it fit into commercial tools such as yours?
So crowdsourced testing, yeah, how popular is it? Well, that's kind of subjective, but it certainly has grown, as you can see with the 2 case studies. It's certainly popular with many large organizations, very popular organizations. Crowdsourced testing for us, we're actually agnostic to the sense that if you're doing crowdsourced testing, the results can actually be inputted into our system. So our ALM system is will take various types of formats of data. So it really what it comes down to is those resources that you're using from a crowdsourced perspective. Chances are any kind of software they're using, they can input that in some shape or form into our product for management.
All right, thank you very much. That ends our event for today. I'd like to thank our speakers, Reg and Jim, for their time, and I would like to thank Polarian for sponsoring the event. Also, a special thank you goes out to you, the audience, for spending the last hour with us. Have a great day. We hope to see you at a future event.